Hello everyone, welcome to Creative Minds Education. Today we are going to start a chapter of class 10 science, which is chemical reactions and equations. So before we start the chapter, we consider the following situation of daily life and things what happen when. First, when food is digested in our body, what happens? Food changes chemically, and chemically means it is change in state. It can be change in color, can be evolution of a gas, it can be change in temperature. All of these fall into a chemical changes. And another example of chemical change is when food is cooked. All of these property will happen. So in all the above situation, the nature and the identity of the initial substances have somewhat changed. Wherever a chemical change occurs, we can say that a chemical reaction has taken place. From the above activity, we can say that any of the following observations helps us to determine whether a chemical reaction has taken place. As I already mentioned, it can be change in state, it can be change in color, it can be evolution of gases, it can be change in temperature. As we observe the changes around us, we can see that there is a large variety of chemical reactions take places around us. We will study about the various types of chemical reactions and their symbolic representation in this chapter. So, continue. Chemical equation representations. How we can represent a chemical reaction or equation? There are two types of ingredients, like first one called reactants and second one is called product. When two reactants combines together, they gives a product. So for example, when magnesium and oxygen combines together, they gives magnesium oxides. Here magnesium is a reactant, oxygen is a reactant, and they gives a product which is magnesium oxide. Now we come to another important topic, which is called balanced chemical equation. Balanced chemical equation means chemical reactions which have different types of elements have same numbers of atoms in reactants as well as in products. Here a table which I have shown to you represents that element Zn, which is a reactant, have only one atom, and in products there is also one atom in the reaction. It shows zinc element is balanced. Therefore all of the other elements also follow this property. Now we have to learn about the types of chemical reactions. There are four types of chemical reactions, which are: first one is combination reaction, second one is decomposition reaction, third one is displacement reaction, and fourth one is double displacement. Now, what is a combination reaction? Putting furniture together, combining ingredients to make something delicious. These things can be fun activities and we look forward to the results. Each individual component is not very exciting by itself. However, if we put together all these individual components, we can make something more complex and exciting. In short, we can say that when two reactants put together, they gives a combined product. This is a property of a combination reaction. In the same way, in chemical reaction, you can combine two or more reactants to form a new product. This reaction is classified as a combination reaction, which can also be referred to as synthesis reaction. In general, a combination reaction look like this. image which I have shown to you, where A and B separately is a reactant and they gives combined product AB. The reactants A and B combine to form a single product AB, which is always a compound. An example of a combination reaction is when hydrogen and chlorine react to form hydrochloric acid. The image shown that hydrogen, which is in solid state, plus chlorine, which is in a gas state, both of these are reactants, gives a product of hydrochloric acid, which is called HCl, and HCl is in the form of gas. This is the whole structure of a combination reaction. Now another topic. What is a decomposition reaction? A decomposition reaction occurs when one reactant breaks down into two or more products. It can be represented by the general equation, that is AB gives A plus B. Here a product breaks down into two different elements. Here a reactants gives two different products. In this equation, AB represents the reactant that begins the reaction, and AB represents the products of the reaction. The arrow shows the direction in which reaction occurs. Now take a question. What is the chemical equation for the decomposition of hydrogen peroxide to water and oxygen? Answer is the equation for this combination reaction forms like this. H2O2 gives H2O and oxygen, which is already said in the question. So we have to represent this question like this. Okay. Now another decomposition reaction occurs when water breaks down to produce hydrogen and oxygen gases. This happens when an electric current passes through the water, as illustrated below. The equation for this reaction same as we studied previous example. Here apparatus shown in the figure filled with water having a connection over a battery. When current passes through water, we contain hydrogen and oxygen gases separately. Now another topic is displacement reaction. What is a displacement reaction? Displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its compound. Both metal and non-metal take part in displacement reaction. For example, here two phases of a laboratory experiment. First one before reaction and second one after reaction. There is a test tube which have a copper sulfate solution having an iron nail in it, and we saw that after reaction the copper sulfate solution converted into ferrous sulfate solution and the color of the solution have changed. Also shows that there is a chemical reaction which have the first point I have already told you. Whenever a chemical reactions happen, there is a change in state or change in color. Here we show that there is change in color, so we can say there is a chemical change in that experiment. Now a question: how is the chemical reactivity of metal linked with their positions in the electrochemical series? Chemical reactivity of metal is linked with their relative positions in the activity series. Certain metals have the capacity to displace some metals from the aqueous solution of its salts. Examples are halogens. The activity of the series of halogen is in ascending order, I have told you fluorine, then chlorine, then bromine, then iodine. This is the chemical series of chemical reactivity. Now, not a point, an important thing to remember with single displacement reaction is that elements that form cations can only displace cations and elements that form anions can only displace anions. There is a table we can learn further in the class. Now, last, what is a double displacement reaction? So let's imagine ourselves going to a dance party, and we going to dance over there and having a dance partner. Once we arrive, we interact with the other people and we end up switching dance partners with another person. Now you end up with a new dance partner. The same kind of thing can be compared to what occurs in double displacement reaction in chemistry. This double displacement reaction, also known as a double replacement reaction or metathesis, is a type of chemical reaction where two compounds react and the positive ions called cations and the negative ions called anions of the two reactions switch places, forming two new compounds or products. Here you can see the general form of a double displacement reaction. There are reactants, there are products, the reactant switches between them and gives a products. A and C are cations which have positive ions, and B and D are anions which have negative ions, shows in this double displacement reaction. So how to complete a double displacement reaction? There are three steps. Step 1, identify the individual ions from the reaction and their charges. I try to explain you that we have to find out the cations and anions for that reaction. A cation has a positive charge and an anion has a negative charge. Now we come to step 2, switch the cations and anions of the reaction. Then we can study from this diagram. You can see how we can switch it to with the reaction. Now we come to step 3, balance the chemical reaction. The reaction in this case is not balanced because the number of sodium and hydrogen atom is not the same. Here in the diagram we can see that sodium has 2 atoms in reactants and 1 atom in the product section. So we are trying to balance these unbalanced things. Now what we need to do next is to balance the reaction by adding coefficients, which are the numbers before each compound. Numbers before each compound means we notice that sodium has 2 atoms in the reactant and 1 atom in the product. Now we have to balance these uncertainty between them, so we have to multiply by 2 in the product section, and in the results we get a balanced chemical reaction. Now move into the next topic, which is oxidation and reduction. Oxidation means addition of oxygen to a substance or removal of hydrogen from a substance. And the next topic is reduction. Same as oxidation, here addition of hydrogen or removal of oxygen from a substance. Now combined we can say those reactions in which oxidation and reduction occur simultaneously are called redox reaction. Now what is oxidizing agent? So the substance which gives oxygen or substance which removes oxygen called oxidizing agent. Similarly, reducing agent, the substance which gives hydrogen or remove oxygen called reducing agent. For example, number 1, we have an equation CuO plus H2 in gas state gives a product Cu plus H2O in liquid state. Now CuO is reduced to CO, we can see clearly from the equation, and H2 is oxidized to H2O because hydrogen gas reacted with oxygen and gets a product H2O which is include oxygen in it. That's why H2 is oxidized to H2O, and CuO is the oxidizing agent and H2 is the reducing agent. Now Example number 2, we have equation S2S hydrogen sulfide plus chlorine gives a product S plus 2HCl means sulfur and hydrochloric acid. Here we clearly see that S2S is oxidized to S. S means sulfur, and chlorine is reduced to HCl means chlorine is the oxidizing agent and S2S is the reducing agent. So now we can say that the substance which gets oxidized is reducing agent and the substance which gets reduced is oxidizing agent. Now we can learn a common topic which is corrosion. It is the presence in which metals are slowly eaten up the action of air, moisture or chemical. For example, rusting is a form of corrosion in which iron is eaten up by the action of air and moisture, and a reddish brown coating of iron oxide is formed as shown in the following chemical reaction. Rusting means rusting is on a iron. When iron is placed in a moisturizing environment, then iron reacts with air and the results gives a corrosion. Corrosion, here is a chemical reaction in the figure. Fe plus S2O. Fe means ferric means iron. When iron reacts with water, we have a process which called corrosion. So now next, rancidity. Rancidity is another topic. When the substance containing oils and fats are exposed to, they get oxidized, became rancid, due to which their smell, taste and color changes. Rancidity occurs when there is a change in smell, taste and color, like when butter is kept open for a long time, then its smell, taste get changed, means there have some sourness in the butter. Similarly, this process is known as rancidity. Now we should have a small overview and some important question on this chapter. First one is, some crystal of copper sulfate were dissolved in water. The color of the solution obtained would be blue. Blue is the answer. Second one, when dilute HCl is added to zinc pieces taken in test tube, then small bubbles of H2 gas appears on the surface of zinc pieces. Question number 3, chemical rust is a hydrated ferric oxide. Question number 4, dissolving sugar is an example of physical change. Heat is evolved Darwin combustion reaction. That's all for now. We will come with our next chapter very soon. Till then, subscribe our channel and visit on creativeminds.net.in for arrange your personal classes at your home. Thank you very much for listening. Thank you.